All right, so I'll kick off. Welcome, everybody, from the HBK virtual conference. I'm Mitch Marks, Business Development Manager for HBK's Electric Power Testing Solutions, and I am here today at Millbrook Revolutionary Engineering. As you can see, I'm not actually here. We are doing this digitally. For all of you who don't know, Millbrook Revolutionary Engineering is a leader in dynamometers and rotational machinery testing. They have a really long history with electric vehicle testing and electrical automotive testing going back kind of to the beginning. And I've had the pleasure of working with them on several projects now. And I've always enjoyed it, and I always learn a lot. And we thought having a conversation with them around testing of rotational machinery would be very interesting. Today, I am joined by Kelly and Matt. If you guys could introduce yourself, we'll start with Kelly.
Yep. Again, as Mitch said, I'm Kelly. I'm one of the test engineers here at Millbrook Revolutionary Engineering, and I've been with the testing group for just over a year now.
And I'm Matt. I'm also a test engineer. I deal with a little bit more some of the controls aspects, and I've been an engineer here for a year and a half.
All right, cool. So we got some questions here. We're going to talk about testing, and we'll just jump in. So while I'm not in your building today, every time I come to run a test, the layout of the building is different. There's forklifts moving equipment. There are guys machining parts, some gals machining parts, new walls, new buildings. What's going on? What are you guys doing?
Really, we're just expanding all the time. When I started here, we had about maybe 12 test cells, and now we're getting closer to 20. So we're just growing. As more demand comes in from customers, we just need to get bigger to accommodate everybody. Test cells get bigger, they require more power. It's the bulk of it.
Yeah, Kelly, do you have anything to add on that?
Yeah, just like Matt said, we're constantly growing. You know, we do a lot of driveline testing is our main. So for us, that's just a constant growing demand, and we've, pretty much tried everything under the sun that has to do with driveline testing, at least at some point. So constantly have something going on around here.
Cool. So you mentioned driveline testing. In the intro, I mentioned dynamometers, which are a big part of the offering you guys have for services and for capital equipment. Kelly, can you comment on what a dynamometer is for everybody who might be new to rotational testing?
Yeah, so dynamometer is basically just the giant motor that we use, and it does the readings for our speed and torque control of our driveline testing. So basically that's how we're doing our measurements for, simulating the real world speed and torques that we're testing on these parts provided by customers.
Okay, so you're putting a customer machine on a big chunk of metal, and that big chunk of metal is basically acting like the road. Is that a good way of summarizing it, Matt?
Yeah, we simulate torque to kind of simulate the road conditions against, say, the axle, or to simulate wheel speed. So yeah, it's a really good way to describe it.
Great. And then to kind of take a step deeper, what type of tests are people kind of commonly doing? I guess what's the top 3 tests that you're doing on a dynamometer? Matt?
So our bread and butter, it used to be our bread and butter, which is the standard T-rig axle. So you just have a giant consumer vehicle, like you see on a giant semi truck, or like on any type of heavy machinery, and we would just do one input with 2 outputs. So we have, say, input torque and output speed. Another really popular one now is e-motor testing, where we do a similar setup as the T-rig, except you have an electric motor being powered by high voltage, and you're applying torque with that and applying an output speed. And a third is more, we do different transfer case testing. So we do try to simulate different heat conditions and try to maintain heat temperatures for customers.
Okay. And Kelly, the customers, are they looking for, durability, efficiency, all the above?
All the above, yeah. So we do a lot, honestly, a lot more of our testing has become kind of research and design testing. Just customers want to find out what their part can do. But like you said, we do the durability testing as well. And then a lot of efficiency testing. Sometimes it's just temperature testing to make temperature maps of at certain speeds and torques, what we're seeing. So again, it's a wide range of things, but I think now we're seeing a higher influx of the research and design testing that's coming in. Cool. Just to kind of learn the parts more.
Yeah. So, kind of understanding the whole electromechanical system. That's great. So Kelly, for you, every time I do a test at your facility, it goes very quickly, and I mean that as in there's a high efficiency in testing. We come in, we set up, we test, we're out. Do you have any comments on what goes into keeping that high efficiency for a test setup?
Yeah, so I think honestly one of the biggest things for us is just having a lot of resources right here on site. So usually we get a new test and everything we need we already have. So it's just a matter of getting the setup completed, getting the control side done. But equipment wise, we have it all. We've got the dynamometers ready. We've got our, HBK torque cells, our E-drive systems, whatever we need to complete the test. And just, being a testing house, it's something that we are constantly doing. It's our day in and day out that, we get a new test. This is nothing new for us, that we're just able to, having done it for a long period of time, turn it around pretty quickly.
Yeah. And Matt, to kind of follow up on her point, she said when you set up this test, it's not only the mechanical, but the control setup. How much can controls change from test to test? That seems like a really interesting question.
It's quite a bit. So don't get me wrong, a lot of customers run similar tests, but then, especially with a lot of these R&D tests, there's so many different requirements and different speeds. So from a control standpoint, you have to worry about if you're using a CAN interface with like vector FDX, or maybe we need more efficiency. So we'll hook up like an E-drive system and need to bring that data into our software so that we can provide it to the customer. So from a control side, it's pretty wide ranging, about as wide ranging as switching out the dynos on what different customers need.
Yeah. Okay. So it's really, every test is a little bit of a unique butterfly, and you need to make the whole data acquisition, test system, device under test talk to each other, and that to me sounds like incredibly difficult. I haven't asked a question on acquisition. I could have there, but we've got some more in the future. I think we'll get to that. So I recently read on LinkedIn a post that somebody at Millbrook had made about testing during COVID and how it's impacting your testing. Can either of you share about the impact that COVID has had on your testing facility?
Yeah, so I think for us, it's been quite a learning curve to try and adapt to, the remote testing, just obviously because there's a lot going on, a lot of physical demand that is involved with the testing. But we've actually been able to, move a lot of our testing remote. We've moved a couple of our test cells to be fully controlled remotely. We've implemented cameras on all of our test cells so we can watch them from a different location. We're able to remote into our PCs that control the test cells. So that's been super convenient for us to be able to check in on things when we're not on site. And then just being able to keep up with customer demand a little bit more, and working with customers has actually kind of improved on our side of our relationship with the customer. And just overall being able to kind of communicate more, being remotely, having to communicate internally amongst our coworkers and whatnot to make sure everything's up to speed and running what we need to. So I think there's just been an increase in communication, which has been a positive for us in terms of testing.
Yeah. So that there's an interesting tidbit there that I'd like to highlight. You said it's actually improved the relationships with the customers, and could you, Kelly, just add a little bit more to that? I mean, detail on that would be great.
Yeah, absolutely. So with the customer relationship, it's just requiring us to be in contact with the customer a lot more. So we're able to, video call, just send quick text message to get, daily updates of what we need testing wise, just a lot more interaction. We're able to get them data via, remote sharing or transfer, files versus them coming into the the facility here with their USB drive or whatever, like we used to do in the past. It's just a lot quicker. They're able to get on and kind of work on the cells in certain situations, so they don't have to be here, and it just kind of speeds up the process, and I think has really, again, increased the communication, so we're constantly hearing what they want, hearing if there's things that need to be changed, if there's stuff on our side that we need to make them aware of. So I think it's just really increased and been a very positive effect in terms of customer relationship.
Yeah, that's so cool. It's put the focus on the tools we already had, but it makes us use them. To also pick another point from your answer on the COVID testing, and I'll point this one at Matt to spread it out. You guys had mentioned that you've been able to actually implement a lot of things remotely and operate them from a remote location. What tools have allowed you to do that? I mean, is it software? Is it communication? What's going on there?
So it's software and hardware. So we, like Kelly said, we went in and installed video cameras on every single one of our test cells, and that we can see what's going on the test cell from every single computer that's connected to the cell. So we can remote in using, we use TeamViewer software. We're able to remote in, and we can actually see what's happening on the cell. So before, when a customer would have, or when a cell would go down, a technician would send us a text message or phone call saying, there's an acceleration spike or something that we need to look at. Mm-hmm. And before, we weren't able to actually physically look at it, whereas now we can remote in, see what the fault was on our software, mm-hmm. and like what the data looks like, and then we can also physically take a look at what's happening. And we're able to get the cells running a lot quicker than, say, maybe waiting the full 12 hours till the next day.
Okay. Yeah, so just bringing everything into a central location just creates so much power, and having everything in one software suite. Yep. So moving on to my next round of questioning. Electrification is absolutely booming business. We kind of all know this. Everybody at this conference today is on electrification day. We got silicon carbide this, gallium nitride that, pancake, axle, hub motors. Everything is constantly changing. How does testing change? How do you guys deal with those kind of technology that are going 1,000 miles an hour? Matt.
So as you kind of said, everything's constantly changing. A lot of what we do is we try to take what our customers are requesting from us and stay ahead of the curve. So with every customer, there's some new requests. So we use that to keep looking at, like, look, we saw this once, it's going to keep happening. Another customer is going to want to start using high precision, high accuracy recording. So we're going to stop focusing on, lower end resolution, maybe start switching all of our test cells to being able to run a higher end data and analysis tool. Or like now with electrification, we still only have a couple bat sims for simulating a high voltage, and now we have double or more than 5 times that number than when I first started. So we're constantly seeing what the change is doing in the industry and just growing to try to stay ahead and stay with that.
Okay, so really, it sounds like, if I'm reading between the lines here, by doing a lot of testing, you're able to keep up with really what the cutting edge is and learn from that on the fly.
Oh, exactly.
Cool. So Kelly, on that same note, in the last 4 years, I've been working for like 6 years now. I assume you guys are about the same. So let's call it the last 4 to 6 years. This whole electrification thing has gone from 0 to 100. Have dynamometers changed much over that period, or even, let's say, the last 15, 20 years? Has the actual instrument of the dynamometer changed much?
The dynamometer itself hasn't changed much in terms of how it operates, how it's built, any of that, but they have just gotten, faster, more power. We're seeing a lot higher speeds in some of the test requests that we're getting in, just a lot higher power points that customers do want to hit. So for us, over the years, we've seen that changing on terms of what dynamometers we need on site. And I think the biggest thing, though, is they have just gotten larger. We're able to do higher power from the newer dynamometers, but overall, the main idea and design of them hasn't really changed.
And circling back a little bit to one of the previous questions, one thing you had mentioned that changes from test to test, and I imagine has changed over time, is the control. Has there been anything significant that's changed on the control end that you've seen or can note about? And we'll start with Kelly, but open to either of you.
Yeah, I think the biggest thing for control in terms of kind of what customers want to see is just higher data acquisition rates. So we have better control of on our side in terms of how we're controlling torque and speed, and just abling to correct like our torque control quicker by getting faster feedback from our torque cells or whatever equipment we may be controlling off of. So I think that's been a change that has really increased in the last couple of years that we're seeing, and just is being more demanded in the industry.
Okay, so really just kind of that tighter response time, faster testing, more stiffer speed controls. Matt, do you have anything to add to all of that?
I mean, that's basically it. Is customers want to see that with more power comes the need for higher accuracy and higher capability. So, torque cells have gone from maybe a 5,000 Newton meter to now 30,000. Like it's been increasing over the years. Additionally, there was a time when 1,000 hertz of recording was really, really fast, and now, I mean, we need high precision setups, kind of like the eDrive that you guys provide, just so we can get something more like 20,000 samples a second, so a customer can actually see the full sine waves of like what their motor's doing.
Mm-hmm. So that brings up a great point. Kind of in addition to the hardware, you've mentioned sampling rates as far as how measurement has changed. Are there any other changes you've seen in how you've done measurement? And like I said, even the last 3 to 4 years?
So just using like our current EtherCAT system, everything's able to be integrated into like one system. So our rep software, we can bring all the different signals in directly and actually display the graphs on our single screen. So you don't have 10 different interfaces in front of you. You have one nice software package that you can see all the different data sampling that you're looking at, and then output it all into one easy file format for the customer.
Beautiful. Kelly, do you have anything to add to that?
Yeah, I think honestly too, with our software and whatnot and everything that we've implemented into it, again, going back to, the biggest help with COVID is that we're allowed to do a lot of our testing automatically. So a lot of customer requests can be done. Just, we just hit go, and everything within our software is all controlled, and we're able to just kind of watch the test. So again, on the control side, we tell the dynamometers and what speeds, what torques we're trying to achieve. And just on the control side, again, with the high data acquisition, we're hitting our precision points very, very well, very accurate. And it's just really a cool implementation that we've had, in the last few years that has come around, that we're, not needing to sit there and run every point manually. We can just say, okay, here's our request, and we put it in and just hit go, and just obviously monitor for any issues. But on our side, that has really, increased, I think, in the recent history of how we've done testing here.
Yeah, that's actually a really interesting point, because you kind of both hit one side of each side of a coin. Matt, you kind of talked about the higher acquisition rates and the higher sampling rates that the customers probably need for their device under test. But that's also useful for the control system, and giving that tighter feedback to the control system on the reps end or on the Millbrook end. So it really kind of fascinating point that, higher sample rate, higher accuracy, higher integration from a testing point of view really helps the control system as well as the customer or the device under test. So really interesting perspective added there, that it's not just the device under test, it's also the control system. Moving on to part 3, when I come in to run a test at your guys' facility, I usually have a mad scientist project, and the most recent of which being torque ripple. And torque ripple, I think, is an example of a test where you need to have really high-end sensors, really high-end acquisition, and then you need to have a dynamometer and test system in place that can hold a really stiff speed and has a really reliable control. So this test requires a lot of equipment, and I just walk in and run the test like it's nothing. You guys just have all the stuff there. Can you guys share a little bit on the equipment you use, HBK or otherwise, that allows you to do these mad scientist tests when a guy like me just stumbles in? I'd start with Kelly.
Yeah. So I think Matt mentioned a few of them earlier, but some of the bigger equipment pieces that we rely on is obviously like from HBK is the eDrive system, the HBM torque meters that we're using. So those allow us to get, like he mentioned, some really high sampling rates for customer. We also have battery simulators, like Matt mentioned earlier, on several of our cells. So that has allowed us to kind of keep up with the demand for the electrification testing that we've come across. Power analyzers is another one that we're using more frequently on our testing to kind of achieve some of the more mad scientist projects that have come into the shop. But I think just big picture wise, what gives us the capability is just, again, it's something that we've been doing for a while, so we can take our base of testing knowledge and, as they get more complicated and we're seeing, different test request things we haven't seen before, we're able to kind of build off of our foundation of what we use, as our bread and butter for day in and day out testing, and then implement that, make changes to what's needed to meet those requests that, sometimes can seem impossible at first glance. But just having all the equipment and resources right here, I think, has been what's allowed us to keep up with the demand and keep up with the crazy off the wall requests that we can spit out pretty quickly.
Great. Matt, do you have anything to add to that?
Yep, kind of where Kelly went with it. So we build cells for our customers and also run a lot of tests. Our customers want to see, certain equipment being used. Like they are using HBM torque meters and HBK power analyzers. So we also want to be using the same kind of equipment so that it's a really easy transition process to giving them what they're already used to looking at, or seeing the same accuracy and precision that they're used to getting in their own facility. And so since we are so big and able to move things around all the time, it's just convenient to have the same thing on all of our test cells that our customers are currently using, so we can just kind of plug in and play the best to our ability, with the limitation of what the changes are in the test that it's going to be.
Okay. Yeah, and I'll chip in a little bit just because I've had some experience there. Is that really if you bring in any sort of test, there's the equipment on site to reconfigure the physical setup of the load machines, drive machines, and have that closed loop control because everything's coming into a central location. So it is really smooth operating where you have the knowledge on site to execute these types of tests. And I think that can't be understated is the knowledge that guys like you bring. So the ability to do these complex tests, obviously not everything is an off the walls test. How does that help you with the day-to-day, kind of the more standard tests? Matt.
So just having a ton of people working here, so we have a lot of different employees that are more familiar with, say, eDrive tests versus or e-motor testing versus the simple T-rig axles. So having it's normal day-to-day tests, it's easy to set up and get all of our automation set up correctly in our rep software, and then hit play and let it go for 24 hours of runtime, and then we can transition over to a different test cell and put a little bit more focus onto a more R&D time-consuming setup process. Yeah.
So again, we keep coming back to this kind of automated testing where you have everything coming into one place and you can just hit play. I think I got to do that a little justice. Kelly, could you kind of just take a step back and describe, what this whole hit play thing is? Like, just give me a little blurb on that.
Yeah, absolutely. So technically with the customer requests we receive, usually we're given speed and torque points that we want to hit on. So we create what we call profiles, and they're just our way of telling the dyno throughout the test what points we're hitting, how quickly we want to get to those points and ramp rates that we're doing, what voltages we want to see, those type of things. So as the test engineers, we take the request and we build these profiles to run the requested points. And then once we finish the profile, we're able to just say, run this profile, and it'll hit all the points that we have told the system to do, again, without us having to do anything past that point of setting up the initial profile.
Yeah. And again, you guys have said it 100 times now, but coming back to that, integrating all these different parts, having that control touch each element of the test, is big, and I'm glad that our eDrive can help with that, and our torque sensors can help with that on the EtherCAT bus. I know you guys are a big user of EtherCAT. So Kelly, you had touched on the next point I wanted to bring up actually was customers are running a test. During the test, they might want to check in digitally in this new era and see some squiggly lines or see some data while it's running for, sanity check. And they also likely want to report afterwards. So I'm going to make this a two-parter. Kelly, could you comment on some of the ways you guys make data visualization easy and maybe some of the things people want to see while a test is running?
Yeah, absolutely. So with our reps software that we use for the controls for the testing, we actually have a live data feed that we can monitor and watch the tests. And that's part of our EtherCAT chain that we get the live data right then while the test is going. So, and to your point of if customers want to see it while it's live, they just can view on our PC, watching our torques and speeds, what accuracy points we're hitting. So usually customers are our biggest things that we monitor right there live while the test is going is acceleration data. We monitor speeds, torques, and then usually temperature is the other big one that we watch live. Okay. Post-processing data after the fact, we obviously are recording a lot more than just those 4 main points. But again, those are usually the big ones that customers want to see. So those are always included in the test report. And we post-processing wise, we usually use Diadem, which is the National Instruments software for data processing on our side. So that's kind of where we'll plot all of our data, make sure everything looks good, and formulate our reports from.
Cool. And then, yeah, Matt, do you have anything to add on the live, or I was going to ask you about the reporting and the text reports you do?
Nope, Kelly was able to touch on all
right, cool.
quite
and
well.
Then,
we're able to get it all into one easy file format that's compatible between different softwares. And yeah, we use Diadem, but you can easily plot into an Excel document without any problems.
Yeah, and Matt, I know you've used our perception software for some of the higher data rate stuff. Could you comment on that and how you guys use that?
Yeah, so we're able to hook that into our rep software using EtherCAT, so we can set up a trigger and tell it when to record, when not to record. We can bring in all the different data that we're collecting through the perception software, and so we can monitor back EMF for different currents and voltages. Yeah. And then additionally, if we need to record at a higher rate than what our EtherCAT can do, which I believe is it's at 1,000 hertz. So say we need to record 20,000 samples, we can just tell the perception software to record, and then we can basically take that and put it into an easy file format, text file, or we use TDMS for Diadem, but any type of file format, and just bring that back into our computer system and then upload it for our customer to look at.
Great. So yeah, the flexibility in reporting seems to be pretty infinite with you guys between the high data acquisition rate stuff and then kind of the slower speed values you're monitoring. A lot of ability there. So you had mentioned kind of our eDrive system. You mentioned the HBM torque sensors. Can you guys comment a little bit on why Millbrook Revolutionary has chosen to integrate some of the HBK product lines? We'll start with, I think, Kelly, you're up.
Okay. Well, I think Matt mentioned it a little bit earlier about, HBK, that's what the customer wants to see. That's the industry standard that, we want to meet. We want to, keep up with what the customer expects to see. Obviously, we're getting great data acquisition from using the HBK products. So it's just something that works really well for us. All of the torque sensors we really like working with because it's quick troubleshooting. It's we can use pretty much same cabling for any size torque we want to use. So if we need to swap out quickly, it goes fast because it's very interchangeable system. So I think that's also another big part of why HBK has been a real big help on our side for the testing and just been integrating for our test cells to be able to keep up with the quick changing and the constantly something's happening that we got to flip it around real quick.
Excellent. All right. So moving on to part 4. And I find this one to be particularly fun. What are some common testing mistakes you guys see? And Matt, we'll start with you.
Cable routing is the biggest one, I'm sure. Between just noise from high voltage cables or the leads going to the dynos, running over a pressure transducer signal or one of our E-drive wires. I mean, noise is everywhere with these, especially with ground loops being what they are. So cable routing is by far probably one of the bigger hiccups that we come across.
Okay. Kelly, you got anything to add to that?
I think on the other side of it, we also see a lot of just running dynamometers and drive systems that can't do the power points that we're trying to achieve. So some of the testing we'll see, customers are trying to hit, say really high speeds, fairly high torque, but the dynamometer is, nowhere close in power to what they're trying to reach. So I think that's kind of one of the common mistakes that we'll come across in terms of a customer either bringing us a test that they weren't able to do because they didn't have the equipment that they could, or just something that we come across, our drive doesn't fit our dyno size type thing that we need to upgrade in size of power that we can achieve those points. So I think that's another kind of common thing that we see mistake-wise in testing.
Yeah, and I would largely agree with both of those statements. So being the data guy and the electric power measurement guy, we see a lot of people need to rerun tests because they've made mistakes like, having DC lines run in parallel with high frequency lines, or having, missing high power points, or having the machine overheat because their dyno or load machine was underpowered. I think you guys have alluded to a lot of the points, but let's just put a cherry on it. Do you guys have any secret sauce for avoiding a lot of these kind of mistakes that result in rerunning a test? The best test is the one you never have to run. How do you avoid, needing to rerun tests?
Oh, I'd say the second best option is to do it all the time. So, constantly doing the same testing makes you a better test engineer. So that's kind of what it comes down to is, the first test you run is probably not going to run great. There's no way around that. But, the second test gets better, the third test. And when you start running different types of tests all the time, you start knowing what to look for. Like one of the first things I'll look for now is high voltage, or to make sure my routing is done correctly to begin with. As Kelly said, hitting the right power points. So you have customers that do want to run specific points that they've never run before. So that's why they're with us, because we have the equipment to do it. And then we can provide them data like, look, this is what we're seeing. And from previous experience, we know that this is a common problem with this type of torque and high speed. So it comes down to just knowledge and having the ability to run so many different tests all the time.
Awesome. Kelly, do you have anything to add to that?
Yeah, no, I think Matt pretty much hit it on the head with that. It's our day in and day out. We're doing it all the time. So, we have a lot of procedures in place that we follow just to kind of make sure that, we're checking everything off. We're making sure that we've not forgotten anything that's crucial for testing, just to make sure that those type of mistakes don't happen and we don't need to rerun it, because, obviously that puts us behind, that puts the customer behind. Nobody's happy when mistakes get made. So just, being very diligent and following procedure on our side has really, I think, been a big help of how we've been able to avoid a lot of testing mistakes.
Yeah, it's extremely hard to put a price on experience, and so many times we see somebody who's they're the control engineer for the device under test, and they design power electronics, and they also get thrown into being the dyno guy. And I think you guys are living proof to the fact that you not only have one dedicated dyno guy, you have probably about 20 dedicated dyno guys, and that experience and that specialization almost can't have a price put on it at times, especially when speed is of the essence. So always good to hear. So things break, and we never intend for them to break, and they don't let me use dynos anymore because I just break things. But things will break. It's the nature of the beast. What are some common things you guys see break in a test cell, and how do you guys deal with that? And I'll start with you, Kelly.
I think for us, some of the common things we'll see is just fixturing setups, wear and tear on our equipment. Usually we don't have like crazy major failures. It's just more of wear and tear. Obviously, we've had a few hiccups here or there, but for the most part, I think just over time, obviously all equipment is eventually going to give out, and we just, again, having the equipment all right here on site. If something happens, if a torque cell goes bad, we're able to just grab another one and get the test back up and running. But I think for the most part, most of the things that we're seeing break, just in general, is a lot of wear and tear over time.
Okay. Yeah. So crystal ball testing electric motors next 5 to 10 years. I know, total shot in the dark, because if you would ask this question 5 to 10 years ago, I'm sure the answers wouldn't look like today. But Matt, where do you see testing going in 5 to 10?
More power, more speed, more torque. I mean, 0 to 60 in 4 seconds was like incredible. Now people want to do it in like, I don't know, 1 second, 2 seconds, like some astronomical speed. Like everybody wants to be the best, the next best, just break all these different barriers. So everything's going to get bigger, it's going to get hotter, it's going to get faster, you're going to need more precise equipment, and everything's going to be growing.
Yeah. Kelly, to add on to that, I mean, what are some of the power levels you guys are starting to see? And I don't need you to spill the beans on anybody's, special projects, but kind of a ballparky, how high are people going with power?
Yeah, I think right now we're hitting about 300 kilowatts. I think that's our high point that we've been seeing people, but there's talks right now of getting 400 or 500 that is around the corner in the near future here. So
that's a lot of power. And on the same side of that question, speed. Testing at high speed is easy when it's 1 kilowatt. Testing at high speed when it's 300 kilowatts is very difficult. How high are you seeing speeds going?
I think in-house, like right now, some of our tests we're hitting around 15 to 20,000 RPM. So we are seeing some pretty high speeds here. And, as Matt said, they're just going up. So.
Yeah, and just anecdotally, I mean, I'm hearing people talking about 25K for automotive, which to me is just like, that's fast. There's
0 to 20,000 RPM in 1 second is a sight to see for sure.
Yeah. I mean, what can go wrong with that type of test if you don't take certain, or I guess, let me rephrase, what type of precautions do you take for a test like that? I mean, there's got to be.
We have safety walking around all the time. There is no shortage of safety conversations just to make sure that we're following different protocols, making sure people have all their safety gear on, glasses, shoes. We have barriers put up so that people can't just walk onto a test cell while it's running.
Yeah.
I mean, 700 volt or 700 amps at 400 volts at any given moment is quite a frightening thing.
Yeah, bolt is going through concrete walls at that point. I mean, from kind of the even the physical test stand, I imagine like the bed plates and kind of even the simple caveman things have to be well thought out and big, just big. Kelly, is that factual?
Yes, for sure. With the test cells, obviously we're constantly growing, so it's actually a really nice implementation that we've been able to do. A lot of our test cells we're able to resize, move around in terms of whatever cells test we're putting on that cell next. So it's very dynamic and able to move. But I think that also kind of goes with a lot of the safety precautions too. Of those are big heavy metal plates that we're moving around that can get really dangerous. But we do have a lot of safety protocols in place and make sure everybody's following procedures. So far we've done very well. We have a really good safety record here. So hopefully we continue on that trend.
Absolutely. And kind of my last question along those lines is you mentioned power, you mentioned speed, you mentioned torque, but we see a lot of things going to higher and higher voltages. And if you just watch the news, DC bus was, we're up at like 900 volts. Can you get either of you, I think Matt, I think you're up, comment on the voltage levels we're seeing and maybe where they're going in the future? Yeah.
So, I mean, even just a year and a half, 2 years ago, things were running, closer to 200 volts was pretty impressive. And now, I mean, a normal e-motor test is running at 350, 400 volts, all the way up to 700 volts. So we had to implement, secondary BASIMs and boosters to try to get up. Our booster can pump up to 1100 volts. So, you're capable of seeing really high voltages, 700 amps. Again, that's over the course of a year, we went from 250, 200 being the standard to 400 is pretty common. So everything's kind of growing exponentially. I would imagine we're going to start seeing regularly, 500, 600 volts coming up here pretty quickly.
Yeah. Okay. Kelly, you have anything to add to that?
No, I think Matt, is pretty accurate on those numbers. We're just seeing them climb. It seems like, every year it's wanting to increase it by 50 more volts that customers are requesting. So, we're having to, like Matt said, implement new equipment here and make sure that our Batsons can keep up with the demand of the higher voltages.
Absolutely. So I'll do a little pitch right there. HBK is very good at very high voltages. So if anybody's interested, we do have a session by Klaus Lang where he will discuss some high voltage measurement techniques. Back to this session though. Last question, closed out. Millbrook Revolutionary, HBK, we have a lot of commonality in kind of philosophies. Obviously, you guys use our equipment, integrate it. I don't want to put words on your mouth, but I think we're friends here. Have you enjoyed working with HBK? And if so, what advantages do we bring to you guys? And we'll start with Kelly.
Yeah, I think we've really enjoyed the relationship that we've formed with HBK. Like I said, the equipment is second to none. It's what customers want to see. We're getting great readings, great data acquisition. It's easy to use. It's easy to, switch out between cells. It's easy to switch out sizing for the torque meters, everything that we're seeing there. And I think just in general, which Matt can touch on this a little bit more, but I think the support that we get from HBK and just in terms of, if we're having any issues with stuff, that's a big help for us because, we are always on a very tight schedule trying to flip things around. And the quicker we can get help in issues that we're seeing, the quicker we can get our tests back up and running and ready to go. So
awesome. Matt?
To keep going with what Kelly said, so I personally love working with the eDrive software setups and the perception software. The last two e-motor tests, I've set up eDrives on them, and it's really quick. So like once you figure out how to do one, the next one is 10 times faster. There's so many good pictures on how to set it up that the first time you look at it, you might be confused by not knowing actually what you're looking at. But then at that point, you can contact support and you'll get an email back within like an hour. But after I got my first setup done, it got pretty well walked through. It's like a walk in the park at this point. Everything plugs in pretty seamlessly. They interface well with all the different transducers that we're trying to use all the time. And then setting it up to work with our EtherCAT setup is pretty seamless. Implementing basically an IP address. It's pretty straightforward. Other than that, the data acquisition is fantastic. So a customer needed me to record something at 20,000 samples a second, and I was able to just hit record and get all my data, put a graph up in front of me and edit it for them right on the spot. So it's fantastic.
Awesome. Your words, not mine. So I would like to thank you guys, Kelly, Matt. Like I said, I've always appreciated working with you guys, and thank you for your time, and I hope everybody out there enjoyed. If you guys have any questions for Kelly or Matt, please feel free to reach out, and we will be happy to help you guys. So tune into the next session and look forward to hearing from you all.